Let's talk about how we would convert from moles of A to mass of B, or if we wanted to convert from mass of A to moles of B. Remember, A just represents the substance you start with, and B represents the substance that you are converting to. And the units here are mole to mass and mass to moles. This conversion will be a two-step conversion using dimensional analysis. And the two conversion factors that you will need are going to be the mole bridge and the molar mass. Remember, the mole bridge comes from the balanced equation. Also remember that the numbers for the mole bridge are counting numbers, so they have unlimited significant figures. One thing that will always be a trend you see with your mole bridge is that moles of A are always going to be on bottom. That's moles of what you're trying to get rid of. And moles of B will always be on top in your mole bridge conversion factor. The other conversion factor that you will need here is the molar mass. Now, it could be the molar mass of A or it might be the molar mass of B, depending on what you're trying to convert to or from. But whenever you calculate your molar mass, I do want to bring a couple of things to your attention here. First of all, the molar mass that you calculate will go beside of the gram and it'll be per 1 mole of that substance. So like if you're calculating the molar mass of A, it'll be the molar mass that you calculate grams of A per 1 mole of A. Notice A and A are the same substance because the molar mass is for that particular compound. If you were going to be using the molar mass of B, you would find that you would have your molar mass, the grams of B, once you calculate your molar mass here, per 1 mole of B. So the mole bridge is the only time you have two different substances in the same conversion factor um, in your dimensional analysis. A reminder, A is your given substance and B is the substance you're trying to convert to or your unknown. Let's look at the template or the plan, if you will, for converting from moles of A to grams of B. You would want to obviously start with your moles of A, and moles of A would be what we call our given. So this is the number that's always given in the word problem. So you would want to be using your mole bridge first. So moles of A on bottom, moles of B on top. This allows moles of A to divide out. And that means next we need moles of B to cancel. So moles of B on bottom here. Now this is your molar mass, which means you're going to be calculating the molar mass of B and plugging it in here. This will allow your moles of B to cancel. And you'll be left with grams of B on top, which is what you're looking for. Of course, this is our answer. Answer goes here, and the answer will have units of grams, and it will be for substance B. So in this particular problem, you'll be going from moles of A to grams of B. So let's look at a problem that would be set up like this. So again, let's underline or highlight our knowns and our unknowns. So here it says what mass of oxygen combines with 2 moles of magnesium in the above reaction. Mass of oxygen and moles of magnesium are mentioned. So I'm going to come up here. My equation is balanced with a 2, 1, 2. By the way, these problems are coming from your notes examples. You have a handout that you were given in class. So this is the same problem that is notes example number 1 for the two-step problems. You need to put your coefficients though. 2, 1, 2 balances this equation. Okay, so mass of oxygen, I'm going to circle the oxygen, and moles of magnesium, here's the magnesium. So we're not going to be dealing with magnesium oxide, it did not mention that. So let's start our problem off with our given 2.0 moles of magnesium. So this is moles of A, and we're trying to convert it to mass of oxygen. The unit for mass is grams, and oxygen is O2 because he's a halogen Hun. Look up here, the formula is O2. Moles of A to grams of B. If you look back at the template, for those of you that might be a little confused, look back at the notes we just took. So we need moles of magnesium to cancel. We're going to grams of oxygen. This is going to be a two-step conversion. So we need to put moles of Mg on bottom. This is the mole bridge. So moles of A goes on bottom of the mole bridge. Moles of B goes on top. In this case, B is who we're trying to convert to, which is oxygen. Remember, I call this the mole bridge because just like a bridge lets you cross over, this is where we're crossing over from magnesium to oxygen in as far as our substances go. This mole bridge, the numbers here come from the balanced equation. So look up, you have 1 mole of oxygen that are needed for 2 moles of magnesium. So the 2 goes here. These numbers come from the balanced equation. Notice this lets moles of magnesium cancel. Now we need moles of oxygen to cancel, and we need grams of oxygen on top. Now this is a molar mass because I see grams here, grams per 1 mole. Now this 1 is here because it's a molar mass. It does not have anything to do with the 1 up here in the coefficient. The coefficient comes from the balanced, is where we get our mole bridge numbers from the balanced equation. But this is the molar mass of O2. So you're going to say for the molar mass, 2 times 16.00, which is 32.00 grams per mole for the molar mass of oxygen. So this will be 32.00 grams per mole. All right, so now moles of oxygen divide out. So now you're going to multiply 2 times 32, which is 64, divided by 2, which is 32. Now we need 2 significant figures because this is our least sig figs. Remember, these have unlimited because they're counting numbers. This has 4 sig figs. So we're going to say our answer is 32 grams of oxygen. Okay, let's look at another example, which is going to be doing the opposite. So in the last problem, we went from moles of A to grams of B. Now we're going to be going from grams of A to moles of B. So this is our template for this. This is going back to your notes. So we need grams of A to cancel. Again, our given is always in the word problem. It's the number that's given in the word problem. And don't forget to put your units and the substance here. So since we need grams to cancel, that means grams needs to go here. This will be our molar mass of A. Grams per 1 mole of A. That will allow grams to cancel. And now you need moles of A to cancel, so you need your mole bridge next. You're trying to cross over from moles of A to moles of B. Again, notice in your mole bridge, moles of A is always on bottom, moles of B is always on top. The numbers for the mole bridge come from the balanced equation. This is your molar mass you will calculate. It will leave you with your answer, having a unit of moles, and it will be for substance B. So let's look at example 2 on your notes examples in your packet. It says carbon disulfide is produced through the following reaction between coke, carbon, and sulfur dioxide. If 8 grams, here's where our word problem starts, 8 grams of SO2 reacts, how many moles of CS2 are formed? So here's the CS2, and it mentions that sulfur dioxide, SO2, they're the substances we're talking about. So 8.0 grams of SO2, that means this is substance A, and CS2 is our substance B. It's who we're trying to convert to. This is balanced with a 5,2,1,4. So let's start with our given 8.0 grams of SO2, and we're trying to convert to moles of CS2. So come over here and put moles of CS2. So grams of A to moles of B, this will be a 2-step conversion. So we need grams of SO2 on bottom, and this will be our molar mass. So we'll put 1 mole of SO2 on top. We want to come down and calculate the molar mass of that, S and O2. So 2 times 16, and 1 times, for sulfur, that's going to be 32.07. Just refer to your periodic table. So that's going to give you 32.07 plus 32.00, which gives us 64.07 for the molar mass. So here we'll plug that in here, 64.07. This lets grams of SO2 cancel. So now we need moles of SO2 on bottom, and this will be our mole bridge. Moles of CS2 on top. The CS2 has a 1, it's a 1 to 2 ratio. Moles of SO2 on bottom. This lets moles of SO2 cancel. So we have 8 divided by 64.07 divided by 2. So you'll get 0.062. And this one's kind of tricky because those leading zeros, sometimes we forget, don't count. We need 2 sig figs here because our given had 2 sig figs. I'll let y'all do the third example on your own.